Today we're going to model real-world situations with inequalities. Let's take a look at the problem below. Angel bought a plant and planted it in a pot near a window in his house. The plant grew at a rate of 3 inches per month, and its height at the time of purchase was 15 inches. So the word rate right here and the word per month clues me in that we might be dealing with our average rate of change. Because on average, the height of the plant is changing by 3 inches every month. And its height at the time of purchase, so its original height when it was purchased, is 15 inches. Its initial or original height. That means at time 0, its height was 15 inches. So this looks like we have a slope and a y-intercept. So we're going to write the equation to model this scenario in slope-intercept form. So my equation is going to look like y equals 3x plus 15. And let me define my variables. X equals the number of months, and y equals the height in inches. So here's our final answer. Now let's take a look at the next question. How many months until the plant is at least 30 inches? So I don't really care about when it's exactly 30. I'm curious when it's at least 30. So when it's 30, or maybe 31, or maybe 32 inches. So I'm looking for all these numbers bigger than 30. So this sounds like we're going to use an inequality. I'm still going to use the same formula as before, 3x plus 15, because this represented the height. But now I want to know, when is the height at least 30? So equal to or greater than 30. Now we can solve this inequality exactly like we would solve an equation. I'm going to subtract 15 from both sides. I'm going to bring down what's left. I'm dividing both sides by 3, and I see x greater than or equal to 5. So this means in 5 or more months, the plant will reach a height greater than 30 inches. Let's review what we've learned today. Inequalities can be solved the same way as equations. Inequality notation will look like this. If you see the line underneath, that means or equal to. And if you see it without the line, that means it's not equal to. Let's take a look at a couple of phrases. Let's say X represents the number of parking tickets Miss Ford receives. Well, if you see Miss Ford can receive no more than 5 parking tickets before her car gets towed, that means X has to be less than or equal to 5. Because if she receives 4, she's okay. If she receives 5, she's okay. But if she receives 6, they're going to tow her car. Now let's take a look at the second phrase. Ms. Ford can receive a maximum of 5 parking tickets before they tow her car. That's the same thing. 5 is my max, my upper boundary. So I would write x less than or equal to 5. Now, Ms. Ford receives a minimum of 2 parking tickets each day. So that would be written as x, the number of parking tickets, is greater than or equal to 2. She receives a minimum of 2 each day. So some days I receive 2 parking tickets, some days I receive 3, maybe some days I receive 8. Now let's see, last week, Ms. Ford received at least 8 parking tickets. I can't even count them all. At least 8 parking tickets. It could be more, but I know it's at least 8. So let's say x is greater than or equal to 8.